Good morning. This is Unit 2, Day 18 notes. This is going to be the last day of trig, and we're going to go over area of a sector. So in geometry, we learned that it's part over whole equals part over whole. Area of the sector over area of a circle equals the degree of a sector over the degree of a circle. And we're going to do this in radians. So I'm going to put, instead of 360, we're going to have 2 pi. So this is going to be, everything we're talking about today is going to be in radians. All right, so when we solve for area of a sector, when we solve for this, we cross multiply, we solve for A, we get A equals theta over 2 pi times pi r squared. The pi's will cancel, and so we get area equals, we still have a 2 on the bottom, so we're going to have 1/2 and then theta r squared. Remember, theta has to be in radians. So this is going to be my area of a sector formula. We're going to need this. So this is the sector. This is what a sector looks like. My r is the radius. I just want to make sure everyone remembers this. And then my theta is in radians, but my theta is my angle right here. Okay. So this is an example. It says find the area and arc length spanned by a sector of diameter 6. So this is not what we want. We want the radius. If my diameter is 6, my radius is 3, it's half of it, so divide it by 2 centimeters, and theta is 0.5 radians. Okay, so all we have to do is plug it into the area of a sector formula, and then we also want to find the arc length. So this one is asking us for 2 different things. So I'm going to find the area of a sector first, and then I'll find the arc length. So my area of a sector formula is 1/2 theta when it's in radians, r squared. It's already in radians, so we have 0.5 times our radius squared. You can just plug this into a calculator, and we get area of the sector is about maybe 2.25, and make sure you write your units. We have centimeters squared. Alrighty, now let's look at the arc length. We learned this earlier in the chapter. Arc length, the formula is easy. It's really easy. We just have to remember it. Let me just choose a different color. I'm going to try red. So my arc length, we usually use S for arc length, is theta times the radius. That's all we have to do. My theta has to be in radians, so it's equal to 0.5 radians times my radius, which is 3. I would just plug that into the calculator, but half of 3 is 1.5 centimeters. Don't forget your centimeters. Don't forget your units. The length of something or the distance of something is just going to be our units. But when we're trying to find the area of something, my units are squared. It says find the area of the shaded region. So we only want this part right here. What we're going to have to do is find the area of the whole sector, and then we're going to have to subtract the area of this triangle. So that's our plan. So we're going to find the area of the sector first. My area of the sector is 1/2 theta But theta has to be in radians, so 1.5. And then radius squared. My radius in this case is 12. And then I have to square it, just the 12. We can just plug this into our calculator. 144, and then 1/2 of that times 1.5 is about 108 centimeters squared. Okay, this is my area of the whole sector. Now I have to find the area of a triangle. So my area of the triangle, this is a triangle symbol, is, usually we say like 1/2 base times height, but we have another formula for it. I have a side, I know if this is 12, then this is also 12, and then an angle, and then the very next side. So if I'm using side angle side, I'm going to use the law of sines, which is 1/2 AB sine C. So this is 1/2. A and B are the side lengths or the radius, so that's going to be 12 and 12. Times sine of my degree, or my radian, which is 1.5. 144 divided by 2 times sine of 1.5 is about 71.8 centimeters squared. So this triangle right here is 71.8. But I found the whole sector, and so if I subtract the area of the triangle from the whole sector, that'll just give me the red part. So the area of the shaded region is 108, 108 minus the 71.8, which is about 36.2 centimeters, and we're still talking about area, so my centimeters are squared. Alrighty, let's try another example. It's very similar to the one above, example 2. Example 3 says, find the area of the shaded region to the left. To the right, sorry, to the right. So we have our angle is in degrees. We cannot have our angle in degrees. You have to change it into radians. So first I'm going to do that. My theta is 135. Remember, we just multiply it by pi over 180. That's my conversion. So 135 times pi over 180, I think that's 3 pi over 4. And now I'm in radians. So this angle is 3 pi over 4. All right, well, my area of the whole sector is, the formula is 1/2. My radius is 7. So we have 7 squared times my radians. My radians is 3 pi over 4. All you have to do is input that into your calculator, and we get something like 57.7. Tell me if I'm wrong. And these are, millimeters squared. Okay, that's the whole sector though. We just want the shaded region on top. So I've got to subtract this triangle. I need to find the area of that triangle. We have a side, an angle, and then I know this side is also 7, so I'm going to use the same formula, 1/2 AB sine C. So 7 times 7 times sine of the included angle, but it has to be in radians. So sine of 3 pi over 4. When we plug this into our calculator, we get about 17.3. If you did not get this, make sure you have your calculator in radians. So you go to mode and make sure your radians is highlighted, not your degrees. Okay. And this is still millimeters. Now, what we need to do is find the area of the shaded region. So what we're going to do, the area of the shaded is the whole area of the sector, which is about 57.7, minus the area of the triangle, which is about 17.3, and that is 40.4 millimeters squared. Oops, squared. Alrighty, guys. What I want you to do is try the other 4 problems. I'm going to give you guys this as classwork to do today, the other practice problems, and I want you to turn it in today. So get out a piece of paper, make sure you guys try these out, and turn them in. Have a great day, guys.